today I am going to teach you about the basics of electronics. Okay, so in the basics of electronics basically come from the word semiconductor, right? Semiconductor. So you should know what is semiconductor. Semiconductor is mainly between the conductor and the insulator. I think you know about it. Insulator is that would not allow the current, right? Conductor is easily allows the current, but in semiconductor it stops some of the current and it allows some of the current. Okay, semi means in between, it is a conductor. So basically, semiconductor has a negative temperature coefficient. I'll tell you what is negative temperature coefficient. And the resistivity of the semiconductor is less than that of insulator, but it is more than that of conductor. Means it is in between of conductor and insulator. Okay, so for semiconductor we are having two examples mainly we'll use. One is the silicon is the example of semiconductor. Another is the germanium is also the example of semiconductor. Okay, for this we'll study like we are having bands. This one is the valence band, okay, and this one is the conduction band. We are having different forbidden energy gap for insulator, for semiconductor, and for conductor. Okay, like as you can see that there is much more gap between the valence band and conduction band, right? So it is the example of insulator. If there is a in between in between distance, like this is in this, the distance between the valence band and conduction band is not so large and is not so less, so this is the example of semiconductor. And if valence band and conduction band overlap with each other, then this is the case of conductor, right? Like suppose I'm giving you an example that valence band, these are having electrons or maybe holes. Okay, so electrons wants to go to the conduction band. Okay, but as you can see that there is a gap between valence band and conduction band is much more, so valence electrons can't go to the conduction band, and this gap is technically known as forbidden energy gap. Okay, and in between semiconductor the gap is less as compared to the insulator, so some of the valence electrons will move to the conduction band and some of the valence electrons can't be able to move to the conduction band. Okay, clear? And in conductor, as you can see that these are overlapping, so in this case valence electrons will easily move to the conduction band. Okay, so basically we are having property. What property we are having? Like for semiconductor we are having property, like suppose I'm taking the example of silicon atomic number is how much? That is 14, that is 284. Okay, so it will form on the sharing basis. You have learned this in the 10th class. One is the ionic bond, right, and one is the covalent bond, right? Can you tell me what is the ionic bond? You have studied in 10th class maybe or 11th class. Hmm. Ionic bond is like just NaCl, like, yeah, transfer the electronic, but covalent bond is completely based on sharing. Okay, so four electrons will semiconductor can't give four electrons to another, and no one will give four electrons to the this semiconductor, so they will do a basis on the sharing. Okay, so in semiconductor they'll always form a covalent bond. Clear? So basically there are two types of semiconductor. One is the intrinsic semiconductor, and another one is the extrinsic semiconductor. Okay, intrinsic semiconductor we can say that it is the pure semiconductor, and extrinsic semiconductor is the impure semiconductor. Okay, pure semiconductor, I think you have listen about this thing, that we can't use the pure gold. Have you listened this thing? Why we can't use the pure gold? Can you tell me? Yeah, we can't use the pure gold because that is in the melted form. For using it, we have to add some impurities, right? Similarly, we can't use the pure semiconductor because pure semiconductor is not in the form where we can use. So for addition of that, we have to add some impurities. And the process of adding impurities is technically known as doping. Yeah, process of adding impurities is technically known as doping. So doping is a very common word in the case of semiconductor. So impure. Now we have to add impurities, right? Either we can add holes on this, either we can add electrons on this, right? Nothing we can add more anything related to that. Either we can add holes on that, either we can add electrons on that. So holes are having positive charge and electrons are having negative charge. If we'll add holes on the existing semiconductor, then that will form a p-type semiconductor because it will carry more positive charge. And if we'll add electrons to the semiconductor, that will carry n-type semiconductor, right? So basically, extrinsic semiconductor is divided into two types. One is the p-type semiconductor and another one is the n-type semiconductor. Clear? So if we are having p-type semiconductor, we are having two things. One is the majority carriers and another one is the minority carriers. As its name suggests, p-type means more number of holes are there. So majority carriers are in this holes and minority carriers means which are less in number, that are electrons. Correct? If there is a n-type semiconductor, then in that case majority carriers are what? Majority carriers are, obviously if there is a n type, then in that case majority carriers are electrons and minority carriers are in that case would be holes, right? Clear? So in how, now the question is how we can make the p type and how we can make the n type. If we'll add pentavalent atom, okay, if we'll add penta pentavalent impurity, okay, that will result in what? N type or p type? Penta means in which we are having 5 electrons in the outermost shell, okay, in which we are having 5 electrons in the outermost shell. If we are having 5 electrons in the outermost shell, then what will happen? 4 will combine, 4 electron will with, yeah, 4 electrons will combine with the silicon and 1 electron will remain extra, right? So that will result in the n type. Correct? If we'll add trivalent impurity, trivalent impurity means trivalent. Trivalent means who is having 3 valence electrons, right? Can you tell me any example who is having 3 valence electron? Boron, sorry, aluminium also. Aluminium atomic number is how much? 13. So it would be 283. So in this case what will happen? There are 4 electrons of silicon, okay, so 3 electrons will combine with that, so one hole will remain extra, that will result in what? P type impurity. Correct? So if we'll see this in the detail, we are having first n type semiconductor, okay, we are having silicon. You know that in the silicon outermost electrons are how much? 4 electrons because we are having silicon atomic number is 14. So suppose this one is the one electron, second electron, third electron and fourth electron. Another silicon is done sharing with another silicon only, like this, okay. Now if we'll add impurity of pentavalent, pentavalent means I told you the 5 atom, Any example for pentavalent? One is you can use phosphorus, right? Another you can use as arsenic, and another you can use it is anti-money, right? So all these are known as donor atoms. You have studied this thing in the 10th class also. All these are known as donor atom because they can give electron. So four electrons will combine with the silicon, one electron will remain extra, and that will be a valence electron. Similarly with the p type, p type we are having one example. I told you that one example is we are having boron, another we can use gallium, or we can use indium. That will create an extra hole that will result into the p type. Okay, clear this thing? Hello, now it's clear. Okay, any doubt up to here? Okay, now in the next, what will happen? As you know that there are two, now you know that scientists, they can't be like, then they have done new experiment. They, what they did, they are having two types of semiconductor. One is p type semiconductor and another is n type semiconductor. P type is having maximum holes, right? P type is having maximum holes and very few electrons, and N type is having maximum electrons and very few holes, right? So what they did, they tried to combine the P type and N type together. Okay, and after that, when they combine the p type and n type semiconductor together, they will form a new device. That device is known as diode. That's why it is its another name is, that is pn junction diode. Okay, what is its another name? That is pn junction diode. So what they did, this is a p type, this is a n type. Okay, then again they did experiment. What experiment they did? Once they have connected the p type with the positive terminal and the n type with the negative terminal. Okay, now let's see what happens. P is for the positive, means we are having maximum number of holes, and n is with the negative, means we are having maximum number of electrons. Okay, so now what happened, in this we are having positive charge, right? In this we are having negative charge, and as you know that holes are positive and positive attract with each other or repel with each other. Positive and positive attracts with each other or repel with each other. Repel with each other, right? So what happens, it will, the holes will form, goes there. Okay, holes will go there. And in this also, negative are there and negative is there. So negative attract with each other or repel with each other? Repels with each other, so it wants to move here. Just imagine that this one, these are the boys, positive one, and these are the girls, negative one. Okay, so boys wants to meet girls and girls want to meet boys, but there is a, we can say, a barrier between boys and girls. Okay, there is a barrier between boys and girls, so we have to remove that barrier. How can we remove that barrier? Tell me. See, we can suppose we they want to remove this barrier, so we have to provide energy, right, to the boys and as well as to girls to break this wall. This is a kind of wall, we can say. This is a wall. We have to provide energy to the boys and energy to the girls, then only we can, they can break the wall now, right? If we don't provide energy to boys and girls, then they can't break the wall. So here we are providing energy. So here you have seen the boys is there, here also boys, so boys repels with each other, so they wants to move towards the girls. Here also girls, I told you, girls with a negative charge, girls repel with each other, they want to boys. So if I'll provide less energy, then they won't be able to break the wall. If I'll provide more energy, then in that case we'll break the wall. That I'll tell you which energy, like how much energy we need to provide. Okay, clear this thing? So in this, what is the main function of diode? That diode, the current should flow from the positive to negative. This is the function known as forward bias. In forward bias, we have connected P with the positive and N with the negative. Clear this thing? Now, forward bias, in case of forward bias, current flows. Okay. Now, scientists, you know that scientists again, they have done a new experiment. What they have done, P, N, they have connected the positive terminal. Now, now it's clear. Okay, now they have again done the experiment. Now they have connected the opposite, P with the negative and N with the positive. Means P are the, these are the boys as you know, and N is the negative, that these are the girls. Okay. No, so this one is the negative and this one is the positive. So boys mean negative means girls and this one means boys. So boys want to meet girls, okay, and in between there is a wall, right? So boys, as you can see that if the boys want to meet the girl, they can move through this path also and meet the girls, right? And if girls want to meet the boys, and they can move to this path and meet the boys, right? So will they try to break the wall? No, obviously they will not do any hard work because they'll get a easily girls and girls will get a easily boys with the another path. So in this case, current won't flow through P to N. Current won't flow through. This one is the known as cathode junction and this one is known as cathode junction. This was anode and this one is cathode. So they don't even try to break the wall, right? So in this case, current will not flow. This type of connection is known as reverse biased connection, and in this case, current will not flow. Okay, in this case, current will not flow. Understood? Hmm? So basically, they have evolved a new device that is known as diode. This is the symbol of the diode. This one is known as anode and this one is known as cathode. Ideally, anode should be connected positive and cathode should be connected negative. Then only in that case, current would be able to flow easily. Okay, clear this thing? So now there is one more thing between the wall, like I told you. This is a anode, this is a P type and this is a N type, and P is connected with positive and N is connected with negative. So between this wall, I technically told you that this is a wall, but technically it is known as depletion region. Okay, technically it is known as depletion region. In normal terms, we can call it as a wall between boys and girls. So if there is a forward bias connection, tell me, depletion region increases or decreases? Decreases. Obviously they try to break the wall, and if they try to break the wall, then that region would decreases. Here are the positive terminals, like holes. For positive terminal, we are having negative ions, the opposite ions, means the acceptor ions. Okay, in n region we are having electrons, in near the electrons we are having positive ions. Okay, we are having positive ions, means the donor ion. You have studied this thing that positive ion will behave as a donor ion and negative ion will behave as a acceptor ion. So as you can see that there is a line of positive and there is a line of negative, right? So in between they form a, like a potential barrier. Okay, this is what this is known as potential barrier. Barrier is a kind of wall and they will form a potential, because one side all the line is positive and one side all the line is negative, so it will form a potential. Okay, and the voltage produced in the this potential barrier, that is known as potential barrier voltage. Okay, that voltage is known as potential barrier voltage. Clear this thing? So potential barrier voltage is different for the different cases. For silicon, I told you that we are having silicon as a potential barrier, right? So for potential barrier voltage for silicon is 0.7. You can mention this thing. For silicon, potential barrier voltage is 0.7 volt. Somewhere it is mentioned 0.7 volt, somewhere it is mentioned 0.6 volt. For germanium, potential barrier voltage is 0.3 volt or 0.4 volt. So both are correct. Somewhere it is mentioned something, somewhere it is mentioned 0.6. Clear? Now I am taking considering it as a silicon case, so I am considering this one as a potential barrier of 0.6 volt. Okay, now suppose if I'll give 0 volt, 0.1 volt, will boys and girls be able to break the wall? No. If I give to 0.3 volt, suppose 0.3 volt, now I increase my voltage to 0.3 volt. In this case, will it be able to break the wall? No. Now I am giving 0.6 volt. Okay, at this time, will the boys and girls, see, I'm giving the energy equal to the potential barrier voltage, the energy which is required to break the wall. Now in this case, current will flow, means they will be able to break the wall. Yeah, in this case they will be able to break the wall. So for that we can draw the VI characteristics. This one is the voltage. Okay, this one is the current. Voltage is in volts here, and current is in like milliampere here, because it is a very less current produces. So we are giving zero point 0.1 volt, little bit amount of current is increasing. Again we are giving zero point 0.2 volt, again little bit amount of current is increasing, like this. We are giving now 0 0.6 volt. At 0 0.6 volt, this wall will break down and current will flow very fast. As you can see that at 0 0.6 volt and between 0.7 volt, current increases exponentially. Why? Because up to 0 0.6 volt the wall does not break, so current would not be able to flow, girls and boys will not be able to move. But after 0 0.6 volt, boys and currents will be able to move very fast, right? And they will meet with their. Now this is the graph of which biasing. This one is a forward biasing or this one is for reverse biasing? Yeah, this one is a forward biasing, and this is the case for the silicon. Okay, if I want to draw the case for the germanium, then that in that case that would be little bit less, like at 0.3 the current would be flow. This one would be the case of germanium. Clear this thing? So at this particular voltage, the which voltage it is, that is known as potential barrier voltage. Okay, these are the cases for the silicon. Clear this thing? Now similarly we'll see for the reverse bias. Again the depletion region will form p type and n type. In p type we are having maximum number of holes, and in n type we are having maximum number of electrons, right? So in this we are having ions. Here which ions will be formed? Negative ions. Okay, and here which ions will be formed? Positive ions. Actually it opposes, like it attracts the opposite ions, that's why. You don't need to go into so much detail, because in your numerical is the main that's why I'm just telling you the basic theory. Okay, Okay, can you send me your previous year papers also? Then according to that, I'll tell you. Okay, now see, in this case we are having, this is for the reverse bias, that P is connected with the negative and N is connected with the positive, right? So now in this case what will happen, the holes will attracted with towards negative ions and the electrons will attracted towards the positive ion. So in this case depletion region will increase, right? So in this case depletion region increases. So if we'll apply, if we want to increase the voltage, like suppose we'll increase zero point 0.1, zero point 0.2, zero point 0.3, then we'll move to up to 5 volt, will they will in that case if we'll increase from zero point 0.1 to 5 volt, they will able to break the this wall or not? Yeah, I am saying that if I'm increasing the voltage from zero point 0.1 volt to 5 volt, so in this case, will the boys and girls will be able to break this wall? They're not gonna break this wall, right? But I'm giving you one more example. Like this is a wall, okay, and here is the flow of water. As you know that current flow is always compared with the water, right? So if we are increasing pressure to the water, okay, so we are increasing pressure to the water. At some point, the wall will break down or not? At some point, the wall will break down, right? Correct. In this also this thing happens. It's not a logically correct, but in this thing it also happen. See how it happens exactly. As you can see that there are the many holes and there are few electrons, right? And in this case many are the electrons and few are the holes. So this negative energy and negative repels with each other. So if we are increasing the voltage from zero point 0.1 to 5 volt, or we can say from zero point 0.1 to 10 volt, so these minimum amount of electrons will get energized, yes or no? These are less in number but they will energize and they will try to break the wall. And we have given lot of amount of energy to these minority carriers. These are known as the minority carriers. So we are giving maximum amount of energy to these minority carriers. So in that case they will be able to break the wall. Okay, but but in that case, yeah, I'm telling you, but in that case, not a sufficient amount of current. The amount of current which is flowing, that is known as the leakage current. Okay, that current is known as the leakage current. It's not the fully current that we got it for in the case of forward bias. It's the amount of leakage current, that is because due to the presence of minority carriers. Clear? So in this case, we as we have, they will, yeah, in starting you have to tell it like that. In starting the current won't be able to flow, but as we are increasing the voltage, supplied voltage, so minority carriers will get a charge and they will be able to break down the, no, it's not a specific voltage. For this we are having a specific voltage like around 0.6 and zero point 0.3 for germanium. It's same for, it's a specific voltage we are getting for the forward biasing, but there is no specification for the reverse bias case. Okay, so again I'm saying that voltage is continuously increasing, and we are not getting the current, but at some point of time the current suddenly increases, and that current is known as leakage current. Okay, that current is known as leakage current, and this one is known as reverse voltage. Okay, or we can say at this particular point there is a breakdown, right? At this particular time there is a breakdown, so this is known as breakdown voltage, or there is another name, it is a knee voltage. It shapes like knee voltage, na knee, that's why it is also known as knee voltage. Okay, This is the case for reverse bias. Breakdown voltage is the voltage, like we are increasing voltage, at which particular voltage current will flow. Yes. Clear?